2.6 and 2.7 is about ratios, proportions, and solving those proportions using cross products. A ratio can be written in 3 different ways: A to B, A to B, and A to B. They're all said A to B and written in 3 different ways. Equivalent ratios. Equivalent ratios mean that I have a ratio that equals another ratio. Sometimes you can use a shortcut by seeing, well, 5 is in the denominator and it has changed to 25. How has that changed? Remember, equivalent fractions are found by dividing and multiplying by the same number. Here I see that 5 has gone up to 25, so if I do 5 times 5, then I also need to do 2 times 5, which would be 10 25ths. Those are equivalent ratios. We have a chart here to fill in. We can see the main fraction is here, 1/5. 1 times 2 is 2, so 5 times 2 is 10. I'm going to go back to the original again because 2 does not go evenly up to 5. So I need to find something that does. Here, 1 times 5 is 5, so 5 times 5 would be 25. The next one, I can see that 5 to 45 goes up evenly. 5 times 9 is 45, so 1 times 9 is 9. These are all equivalent ratios, and they're all equivalent to 1/5. If I was to reduce each one of these, they would reduce down to 1/5. To compare 2 fractions, I can use the cross products, and we have B times C and A times D. That would be the cross products. I can only use this technique when there are 2 fractions. Otherwise, when I'm comparing fractions, if it's more than 2 fractions, then I'd have to find that common denominator and look at all of them. Here, I can use the cross products. 3 times 4 is 12. 5 times 2 is 10. And 12 is larger than 10, so 4/5 would be larger than 2/3. We could also see this again with the common denominator. The common denominator for 3 and 5 is 15. 5 times 3, so 4 times 3 is 12. 3 times 5, so 2 times 5 is 10. We can see that 12/15 is larger than 10/15. So 2 different ways you can compare fractions. The next one would be proportions. A proportion is when you have a ratio that equals another ratio. We could use the shortcut here. I can see that 6 is going up to 30 evenly. 6 times 5. So 11 times 5 would be 55. X equals 55. I do like to use the shortcut in looking at ratios if it's possible. The next one says, write and solve a proportion, and this is the portion. 3 is to 8 as X is to 32. 3 is to 8 as X is to 32. On this one, I am not going to use the shortcut, even though I can see that 8 is going up to 32 evenly. I would like to show you how to solve a proportion, even if there would not be an even jump. Again, I'm going to use the cross products. I can do 8 times X. 8 times X is 8X. Equals 3 times 32. 96. And then what I have here is a one-step equation where I could solve for X, divide by 8, divide by 8, and we get that X equals 12. Looking at a rate. A car travels 120 miles in 2 hours. A rate, 120 miles in 2 hours. That is a rate. And the next one is going to be about a unit rate. All right. A unit rate is where we'd like to have a 1 in the denominator. I want to know per 1, like how much for per 1 hour. That would be 60 miles per 1 hour. That would be a unit rate. We want to know per 1. All right, we have a car travels 120 miles in 2 hours. Find the unit rate for feet per second. Feet per second. So we need a conversion for miles. Miles and feet. I just Googled a conversion. Nothing wrong with doing that when you need something. I have that 1 mile equals 5,280 feet. We need a conversion to go from miles to feet. Right now we're in miles, and our final answer needs to be feet per second. We are in hours, and we need second. So you could say, you could do this in 1 step, or you could do it in 2 steps. I could say that one hour equals 60 minutes. That brings us from hours to minutes. And then 1 minute equals 60 seconds. So I went from hours to minutes and then minutes to seconds. Those are the conversions that we're going to need. These are actually fractions that I want to multiply down here. I see that I have 3 conversions. So I'll be multiplying by 3 fractions then. I'm going to put this one in there first. Miles and feet. There is a definite way it needs to go in here. What I need to happen is my miles need to cancel, leaving just feet. So where would I put miles in the numerator or denominator to get miles to cancel? Miles is in the numerator, therefore I'm going to put 1 mile in the denominator and then 5,280 feet in the numerator. That gets my miles to cancel, leaving feet, which is good. Feet, now I need per second. I have 2 more conversions. Here is hours. Therefore, I'm going to have to put an hour in the numerator to cancel with the denominator. So 1 hour goes in the numerator and 60 minutes goes in the denominator. I can cancel hour for hour. And now I have in the numerator feet per minute. 1 more step and we'll have feet per second. Here is my last conversion. I need my minutes to cancel, so I'm going to put 1 minute in the numerator and 60 seconds in the denominator. I can cancel my minutes, and now I can check my units. If I have feet per second, then I'm ready to do the number crunching. In the numerator, I have feet, and in the denominator, I have seconds, feet per second. Now I'm ready to multiply straight across and then divide out. All right. That would be 633,600 divided by 60 times 60. 6 times 6 is 36 with 2 zeros. And now I am ready to divide this out. So this would be feet per second. That gives us 176 feet per 1 second. That would be a unit rate with a 1 in the denominator. Volleyball team plays 14 home matches and 10 away matches. Find the ratio of home matches to away matches. Well, we have 14 home to 10 away matches. And then I would reduce. I can take a 2 out from both of these. So we're left with 7 home matches to 5 away matches. Find the ratio of home matches to all matches. Home matches to all matches. All right, so we have home matches is 14. What is the total matches? 14 home, 10 away. That would be 24 total. And when I reduce this, I can take a 2 out. That leaves 7 home to 12 total. All right. Elevators. The elevator that takes passengers from the lobby of the John Hancock Center in Chicago to the observation level travels 150 feet in 5 seconds. There's a ratio. 150 feet in 5 seconds. The observation level is located on the 94th floor at 1,029 feet above the ground. Find the time it takes the elevator to travel from the lobby to the observation level. So we have feet and seconds. That's how the first ratio is set up. That's how the second one has to be set up. What did they give us? 1,029 feet. What's the question asking for? Find the time. Seconds is unknown. All right, we're going to cross multiply. 5 times 1,029. And that would be feet, seconds, multiplying your units, feet and seconds, equals x times 150 feet would be x times 150 feet. And now we're ready to solve. X is being multiplied, so we're going to divide by 150 feet. Divide by 150 feet. We see that these will cancel. And what happens on this side? Feet and feet are going to cancel. It's like having a variable, canceling feet for feet, and that leaves seconds, which is good because we need an answer that's in seconds. And now 5,145 divided by 150, 34.3 seconds equals x. Writing proportions from similar figures. These are similar. They're not congruent because they're not exactly the same shape, but they are similar to each other. I need to solve for x. X is on this side of the figure, and so I'm looking for the corresponding side that goes with that. That would be this side. X and 30 go together. Now I'm looking for another ratio. X is to 30 as, well, what goes nice with 30? Is it going to be 9 to 54? Does 54 go together with 30? Or should I use 10 and 60? 10 is to 60. Direction matters. I started on the left and I went to the right. That means I need to do that for both ratios. X is to 30, 10 is to 60. That's one way to set this up. Another way to set it up is I could have said that X is to 10, right is to bottom as right is to bottom. 30 is to 60. So there are different ways to set up these proportions. You just need to make sure you're going in the same direction. On the first one, I went from left to right. On the second one, I went from right to bottom, right to bottom. All right, let's solve this one. 30 times 2. All right, but x times 2 is 10. So let's work backwards. Let's go in this direction. 60 divided by 2 would be 30. So 10 divided by 2 would be 5. Let's check and make sure that these are actually equivalent. We have 60 divided by 6 is 10. So 30 divided by 6 is 5. We also got 5 for this one. Next problem. All right, let's see here. We're going to say that x is to 3. X is to 3 as 12 is to 3. X is to 3, 12 is to 3. The 3 has not changed, so the 12 is not going to change. If I'm confused by this, I could cross multiply. You get x times 3 is 3x equals 3 times 12 is 36. And when I divide by 3 and divide by 3, I get x equals 12. Use a table to write a proportion. Use a table to write a proportion. Here's our variable. Again, there's many different ways that you can write proportions. Let's go with game 1 is to game 2. 12 is to 18 as 14 is to W. 12 is to 18 as 14 is to W. 12 is to 18 as 14 is to W. Cross multiply. 12 times W is 12W. 14 times 18, 252. Divide by 12, and we get W equals 21. All right, the first time I went 12 is to 18, 14 is to W. I'm going to try it differently. Let's go 15 is to 2.5 as M is to 4. Cross multiply. 15 times 4 is 60 equals 2.5 times M. We have a one-step equation, and now we can divide out 2.5, divide out 2.5, and we get M equals 24. One way to check to see if your answer is right is looking at the constant of variation. Is 15 to 2.5 the same as 24 is to 4? So if I divide this out, 15 divided by 2.5, 15 divided by 2.5 equals 6. 24 divided by 4 is 6. We can see that their constant of variation is the same. It's changing by 6.